Here's a simple example of that. We've got a couple sequences, and we want to align them. This is what that would then look like. Here, I'm only considering alignment of a single letter of one of my sequences to two letters of my other sequence. So what we do is we write this as a matrix. The key thing I want to emphasize is in global alignment, we have an initial row and column before we even arrive at the first letter of our sequence. Why? Because we have to allow for the possibility of gaps and insertions in one of our sequences before we even begin to align to the other sequence. You see? As global alignment, we consider every single letter of our sequence, even if it's not yet even aligned to the first letter of the other sequence. So computationally, this is trivial. Basically, at our origin, we just always write a 0, and then under the simple rules that we're following for the programming project, we have just a gap penalty that we apply both for insertion and deletion moves, horizontal moves, and vertical moves. So let's say in this particular case, our gap penalty is -3. So we just start summing -3 along each of these, basically because the only possible way to get to this cell here would be to do one horizontal move, and then the second horizontal move gets you here. So -3 to get here, -6 to get here, -9 to get there, and so on. And the same thing on the vertical. So now, my first non-trivial cell has 3 possible moves going to this cell, that cell, or that cell. So now I consider my match matrix. So we said that this match matrix was +5 for exact match. If it's a mismatch, the two letters don't match each other, it's a -2. If it's a gap, it's -3. So here I have -3 already in this cell. And we have a horizontal move to come here. That would be plus another -3. That would be a total score of -6. For my diagonal move, I've got 0 in the preceding cell, plus 5 for matching an A to an A. That's a total score of 0 plus 5. 5 is greater than -6. So I choose the diagonal move with the same -6 coming from this cell down here. So we write down 5 in that cell, and we write down the traceback move is going to be this diagonal move. And we just keep filling in the matrix in this way. Okay? Any questions about doing Viterbi on this simplified matrix representation? Okay, well, given the time, why don't we end there, and we will resume on Monday.